The greatest technological arms race of our lifetime isn't happening on a brightly lit stage in Silicon Valley. It's not happening in the headline-grabbing announcements of eccentric billionaires, and it's certainly not happening in the traditional century-old boardrooms of legacy European automakers. While the world's attention has been completely captivated by trade wars, rising tariffs, and a daily barrage of flashy press conferences, the real revolution has been unfolding entirely out of sight. When we talk about electric vehicles today, one name almost automatically dominates the conversation: Tesla. We think of their software prowess. We look at Toyota and applaud their relentless pursuit of manufacturing efficiency. We watch BYD aggressively expanding its battery empire across the globe. It feels like a crowded, noisy battlefield where everyone is fighting for a fraction of an inch: America versus China, Europe versus Asia. But what if the entire industry has been looking in the wrong direction? Hidden beneath the deafening noise of brand wars and marketing hype, a massive technological shift has been quietly engineered by a Chinese company named Chery. While the legacy giants have been obsessed with maintaining their market share and repositioning their old vehicles for a new era, Chery's engineers retreated into their laboratories to completely rethink what an electric car actually is. They didn't just build a new vehicle, they built an entirely new philosophy, and what they have created is poised to completely upend a global automotive hierarchy. The question you have to ask yourself isn't whether Tesla will remain the leader. The real question is, are you ready for the shockwave that is about to hit the electric vehicle market? To understand the magnitude of this shift, we first have to understand the fatal flaw of modern electric cars. Why hasn't the promised EV utopia arrived yet? The truth is, most legacy automotive brands are trapped in the past. They are trying to build the cars of tomorrow using a blueprint designed for the petrol and diesel vehicles of yesterday. Imagine trying to play a high-stakes game of automotive Tetris. You have a massive, heavy battery pack and complex electric motors, but you are trying to cram them into a chassis that was originally designed to hold a combustible engine, an exhaust system, and a transmission tunnel. It is a Frankenstein approach to engineering. They slice a piece here, weld a piece there, adjust the heavy steel floor, and somehow try to make it all fit. But adapting an internal combustion chassis to an electric vehicle doesn't solve the inherent problems of weight, space, and structural integrity. It merely hides them under a sleek new exterior. The foundation is compromised from the very beginning. This is exactly where the EOX platform changes everything. This is what engineers call a clean sheet design. It means stepping up to a blank whiteboard and designing an architecture with a purely electric mindset from day one. Instead of the archaic method of taking 70 to 80 separate heavy steel parts and painstakingly welding them together to form the underbody of the car, the EOX platform utilizes aerospace-grade integrated die casting. Think about what that actually means. The same high-strength aluminum alloy used to build commercial aircraft is melted down and injected into massive molds under thousands of tons of pressure. The result is a single, seamless, solid unit. In traditional manufacturing, every single weld connecting those 80 parts is a potential point of failure, a microscopic weak spot that over time leads to chassis flex, vibrations, and rattling noises in the cabin. By replacing that patchwork of metal with one unified cast, the structural rigidity of the EOX platform skyrockets to an astonishing 40,000 Newton meters per degree. Until recently, you could only find that level of torsional stiffness in multi-million-dollar carbon fiber hypercars. Now it is the foundation of a mass-market platform. This means the vehicle doesn't flex when you hit a pothole or take a sharp corner. It delivers unparalleled stability, practically eliminating body roll. It vastly improves safety as impact energy from a crash is distributed evenly across a unified structure rather than concentrated on a single fragile weld. But a virtually indestructible foundation is only the beginning. The real magic happens when you look at how the energy flows through it. On the surface, a jump from a 400-volt architecture to an 800-volt architecture sounds like a simple numerical upgrade. It is anything but. This is a total paradigm shift in power delivery. Today, the vast majority of electric vehicles on the road are shackled to 400 volts. But let's break down why doubling that voltage completely rewrites the rules of physics for a car. Imagine you're trying to fill a massive swimming pool. If you use a standard garden hose, the water trickles in slowly and the hose is under immense pressure. But if you upgrade to a massive industrial-sized pipe, the water rushes in instantly, effortlessly, and without straining the system. The 800-volt architecture is that massive pipe. By increasing the voltage, you require significantly less current to deliver the exact same amount of power. And in the world of electrical engineering, lower current means drastically less heat. Heat is the ultimate enemy of the electric vehicle. It destroys efficiency, degrades components, and wastes energy. But Chery didn't just stop at increasing the voltage. They replaced the traditional silicon power electronics, which are notoriously inefficient and prone to overheating, with advanced silicon carbide. When you pair silicon carbide with an 800-volt system, thermal loss is slashed by a staggering 50%. More of the energy stored in your battery actually goes towards pushing the car forward rather than being wasted as heat that the car then has to expand more energy to cool down. The most immediate life-changing benefit of this efficiency is charging speed. Because the system runs so cool, it can accept a massive influx of power without overheating. With this 800-volt silicon carbide architecture, you can add 150 kilometers of driving range in just 5 minutes. That is a total game changer. The agonizing hour-long waits at public charging stations are completely eliminated. In the exact amount of time you take to stretch your legs and buy a cup of coffee, your car has guzzled down enough energy to drive another 2 hours down the highway. But even with lightning-fast charging, there has always been a dark cloud hanging over the EV industry, a fear that no one likes to talk about. For the last 15 years, the entire automotive world has been locked inside what we can only call a battery prison. The lithium-ion batteries that power our phones, laptops, and current electric cars are an incredible piece of technology, but they harbor a highly volatile secret. They rely on a liquid electrolyte to transfer energy back and forth, and that liquid is inherently unstable. Every time you charge and discharge a traditional lithium-ion battery, microscopic needle-like metallic structures called dendrites can begin to grow inside the cell. If a dendrite grows long enough to pierce the internal separator, it causes a short circuit. This leads to thermal runaway, a terrifying chain reaction where the battery's temperature skyrockets uncontrollably. Even worse is a self-oxidizing fire, which can occur if the battery pack is physically punctured in a crash. Because the chemical reaction inside the battery actually produces its own oxygen, these fires are practically impossible to put out with just water. For a decade and a half, automakers haven't been able to fix this chemical flaw. They've only been able to build thicker armor and heavier cooling systems to manage the risk. That era of compromise ends with the Kunpang solid-state battery. Chery's breakthrough completely eliminates the dangerous, volatile liquid electrolyte and replaces it with a highly stable solid ceramic or polymer-based structure. By turning the chaotic liquid core into a solid, the safety risks are entirely neutralized, while the energy storage capacity explodes. To put this in perspective, industry-leading batteries right now, like Tesla's 4680 cells or BYD's Blade batteries, hover around an energy density of 150 to 290 watt-hours per kilogram. The Kunpang solid-state cells reach an unbelievable 600 watt-hours per kilogram. They're packing 3 times the amount of energy into the exact same physical space. We're no longer talking about theoretical numbers. In real-world practical application, this unlocks a driving range of up to 1,500 kilometers on a single charge. Range anxiety is officially dead. You can drive across entire countries without ever glancing nervously at your battery gauge. But what about the safety? What happens when the absolute worst-case scenario occurs? To prove the stability of the Kunpang solid battery, engineers didn't just run computer simulations, they subjected these solid-state cells to extreme, violent, real-world torture tests. They cut the active batteries entirely in half. They fired ballistic projectiles into them. They drove thick steel nails directly through the center of fully charged cells, a test that would instantly turn a traditional lithium-ion battery into a raging inferno. The result? No explosion, no fire, not even a wisp of smoke. The solid electrolyte simply refuses to react violently. For the consumer, this translates to the ultimate luxury. This surface data is fed instantly through the Gigabit Ethernet to the continuous damping control system, paired with a highly advanced dual-chamber air suspension. Unlike standard single-chamber systems that offer limited adjustability, the dual-chamber setup can instantly alter the physical volume of air inside the shock. Going into a sharp, aggressive corner, the suspension instantly stiffens to keep the car perfectly flat. Cruising down a broken, heavily rutted highway, it instantly softens to absorb the impacts. Coupled with active rear wheel steering, which turns the back wheels in the opposite direction at low speeds to shrink your turning radius, and in the same direction at high speeds for lane change stability, the car ceases to feel like a heavy object rolling on rubber tires. It isolates the cabin so perfectly that it genuinely feels like you are gliding on a magic carpet, hovering inches above the asphalt, regardless of the chaos happening underneath you. We have been conditioned for generations to respect a strict automotive hierarchy. We were taught that the shiny metal badge on the hood of a car was the ultimate guarantee of engineering superiority. We believed that history and legacy equated to cutting-edge technology. But that era is over. True technological leadership is no longer determined by the brand heritage. It is determined by the raw capability of the platform, the safety and density of the battery, and the processing power of the electronic architecture. The convergence of the aerospace-grade E0X platform, the fireproof 1,500-kilometer Kunpang solid-state battery, and the hyper-fast Gigabit Ethernet brain isn't just a list of neat features. It is a complete generational leap. It redefines what an electric vehicle is legally and physically capable of doing. The giants of the old world didn't see this coming, but the rules of the game have just been permanently rewritten.